Hey everybody, welcome to topic number 14. A little bit more about functions. So we already talked much about function, especially domain and range, different types of functions. Um, so in this particular topic, I want to talk about how we can evaluate functions as specific value. All right, so evaluating function as specific value means we're gonna find the y value when given any x value of the function. Or it can be finding the x value when given any y value of the function. So it can be vice versa. So the following way to evaluate function is basically we're going to input an x value and output a y value. So we can either do it by hand, that means we write everything out and then put it in the calculator to figure out what the answer is. We can actually graph the function, then use the table to see, to figure out what the y value is. That's assuming if the x value is a whole number, okay? Or we can use this feature called the graph, using this feature called second calc on your graphing calculator. Okay, so I'm gonna show you multiple ways here for a minute. So for this particular example, I'm gonna go ahead and write it out and put it in the calculator for you. So substitute -1 into the function. So I'm replacing x with -1. So whenever I substitute a number into a function, I always want to put that number inside the parenthesis. So I'm replacing all the x's with -1. So once I write it out, I can just come to my calculator and then just enter what I write. 4 times, oh, excuse me, plus 2 times -1 minus parenthesis -1 whole thing to the third power. All right, so f of -1 is equal to -5. So what this -5 mean is that's the y value. That's one particular y value of the graph of the function. So in other words, we input an x value -1 and we use the function to figure out the y value because remember now, f of x is also representing y. So input an x, so the answer -5 got to be the y value of the function. Now it's one particular point on the function, on this cubic function. All right, so I'm gonna graph this function, show you a different way. So go to y equals -4 plus 2x minus x raising to the third power. I'm gonna graph this cubic function. All right, go to the table feature right above the word graph, color coded. So second graph. So if I go to -1, my y value is -5. Okay. Now another technique is using this second calc feature. So I'm going to press graph again. Second calc, so that means it's right above the word trace. So second calc, choose number one value. So here we can input any value of x. It can be a whole number, decimals, fractions, okay? And then it will give me the output. So I'm going to type in -1 for x, press enter, and then y value is -5. All right, let's try another one. So this is a square root, a radical function, a square root function. I want to substitute a 4 into the function. So I'm going to replace all the x's with 4. This is an interesting one because what we know about square root function, as you can recall from, let me see if I can find it real quick. I believe it's from topic number 10, no, topic number 11. A square root function. A square root function normally look like this. Okay. That's what it normally look like. but not this particular one. Okay, so in a different topic, we will talk a little bit about something called the transformation of function. By looking at the function, by looking at the equation part of the function, we can actually figure out, we can kind of have a sense of knowing what the graph is kind of look like before we even graph it. All right, so let's evaluate, okay? All right, square, this is -1 times 4, so f of 4 is equal to square root is -4 plus 3, then minus 2. -4 plus 3 is actually -1. So square root of -1, as you can recall, is equal to I, right? So my answer here is I minus 2. So that this imaginary number tells me that the graph does not exist at x equal to 4. Okay, so now I'm going to show you what it looked like on the graph. So square root of -x plus 3, close parenthesis, then minus 2. This time our graph is going to the left side. So if I set what's inside the radical equal to 0 and solve for x, like we did before, with the -x over, so x equal to 3. So this x equal to 3 is telling me that this point right here, okay, is actually where my graph ends at. It ends at x equal to 3. So when I substitute x equal to 4, there's nothing to the right of 3. The graph doesn't exist there. That's why the imaginary number kind of tells me that, hey, there's actually no graph over there. So if I go to my table, as you can see, if I scroll down a little bit to x equal to 3, y value is -2, but when I go to x equal to 4, it gives me an error message. So that means my function does not exist when x equal to 4. As you can see in the picture, your graph doesn't exist to the right side of +3. All right, let's try another one. So this is a rational function. Substitute 4 again into the function. So that will be f of 4. So this x, this term x doesn't have anything, with it. It's just a straight up x. So I'm just gonna write a 4 there. So 4 minus 4 on the numerator is gonna be 0. 0 divided by anything is gonna be 0. 2 times 4 is 8, minus 1 is 7. All right, so when I evaluate f of 4, right? My answer is 0. So that means this 0 is a y value. So when I input a 4, okay, my y value is a 0. So this 4 comma 0, so technically this is actually a x-intercept, okay? So real quick on the discussion, when input x value into the function, in no longer what does the output represent? So you can say something like the output represent the y value. So we actually done something like this before. When we learn how to graph linear equation by finding 2 points, right? All that is actually a way, all that is actually evaluating functions. All right, the next objective is evaluating function with an algebraic expression. Okay, so this problem does have a lot of things involved. So it's a good review. So here I'm giving a function g of x, -5x squared plus 2x minus 1, giving a quadratic function. Okay, I want to substitute. Okay, I actually want to take this function g of x and then put into this formula, g of x minus g of a over x minus a. All right, so I already split this whole problem out into many steps. So number one says substitute what the function g of x equal to, which is function g of x equal to that, into the formula. So I'm going to substitute what g of x equal to into the formula, taking up that spot where g of x is. All right, so I'm going to replace g of x with -5x squared plus 2x minus 1. All right, I'm gonna write everything else down. Still minus g of a, still over x minus a. Now I'm gonna substitute the letter a into g of x. So that is for the second part of this, the second term of this formula up here. So I'm gonna substitute the letter a into the formula. So wherever I see an x, now you'll be replaced with an a. All right, let's simplify this for a moment. So a whole thing squared is still a squared times negative 5 is negative 5a squared. Positive 2 times a is positive 2a and still minus 1. So this is what g of a equal to now. This is what g of a equal to. So number 3 says from the correct answer, number 2 substitute what g of a equal to back into the formula that I begin to write in number 1. So I'm going to substitute all this. I'm going to take the entire what g of a equal to into the formula I begin to write in number 1. So that'll be goes right here. Okay, so I'm gonna write down whatever is already there, negative 5x squared plus 2x minus 1. Now I will minus. G of a is 3 terms representing 1 g of a, so I will put those 3 terms in the parenthesis. All right, so let's substitute g of a. There'll be negative 5a squared plus 2a minus 1. All right, whole thing is still over x minus a. All right, so for the answer we just wrote, distribute the numerator because since my g of a, these 3 terms is inside the parentheses, so I will need this negative 1 to do a distribution to bring out these 3 terms. So negative 5x squared plus 2x minus 1 still there. Negative 1 times negative 5a squared is positive 5a squared. Negative 1 times positive 2a is negative 2a. Negative 1 times negative 1 is positive 1. Everybody still over x minus a. All right, so from correct answer I just wrote, combine like term on the numerator. So the only thing I can combine up here is the negative 1 plus 1. So I end up with negative 5x squared plus 2x plus 5a squared minus 2a. Whole thing over x minus a. All right, so now the question is, okay, what do I do? If we recall back in the rational expression, when we reviewed the rational expression back in topic number 6, every time when we're dealing with rational expression, and I mentioned this a couple of times before, what do I do at the end? Well, at the end, we always try to factor and see if anything can be canceled out, right? So when we have a rational expression like written this way, right? All the terms is with all multiple terms top and bottom. We want to try to factor, see if anything can be canceled out, and that's what we're gonna do here. But except this problem is a little bit tricky because this is 4 terms on top, right? So we will need to do the factoring by grouping, and we're trying to use factoring by grouping to help us factor. But how do I group them? How do I group my terms? Well, the denominator gives you the biggest hint. Denominator has x first and a next, right? So I need to group the x with the a. So I'm gonna group the first term, negative 5x squared with the positive 5a squared. I'm gonna group those two together. And then I'm gonna group the 2x with a negative 2a. Okay, and I'm gonna have x as the first. All right, so let's do some factoring by grouping. So negative 5x squared plus 5a squared. Okay, these two terms, the greatest common factor is a 5. But if you look at the denominator, that x is a positive x. So I want this x squared to be a positive. So I need to factor out a negative 5 between the negative 5x squared and the positive 5a squared. Because if I factor out -5 going to -5 is positive x squared times. -5 going to positive 5a, positive 5 is actually -1 times. So if I factor out -5 between those two terms in yellow, this is what I will end up. Between the second and the fourth term, I highlight in blue, I can factor out a positive 2. That's the greatest common factor. And what I end up with is just an x and a -a. There you go. All right. So now, if you look closely, this plus sign right here is separate between two terms. And the two parentheses does not match yet. Because what's inside the first parenthesis here, this is actually a difference of squares. So I get to factor that again, right? Difference of two squares, because I got two perfect square terms. So if I factor that difference of square, I should have x plus a times x minus a. All right, with the -5 is still in the front, and everything else is still there. So now I still, with this plus sign outside the parenthesis, I still got two terms. What match between the two terms are the x minus a. So I'm gonna factor that out, factor out the x minus a, right? Then what's left for the first term will be -5 parenthesis x plus a. And what's left for the second term will just be a positive 2. Whole thing over the x minus a. So since I'm factoring the numerator, I will need to factor the denominator as well. X minus a, there's nothing to factor out other than 1. So I will put x minus a in the parenthesis. There you go. So once I factor the numerator and denominator, then I can cancel out the x minus a. So this is what I should be left with. Okay. So on the homework, the first question is substitute -1 into the function, and then number 2, you evaluate. Question number 2 is on the handwritten portion. So question number 2 is the same one as the one we just did, except I'm using function f. So follow the step like I just did. And at the very, very end, okay, make sure you show the work like I showed you just in class. Okay, and write the answer this way. You don't have to cancel out the x minus a. You can just write the whole thing because we know the x minus a can be canceled out. Okay, so just leave your answer in this format, just like I like I did. Okay. Alrighty, so in this lecture video, we quickly talk about how to evaluate a function using different technique, and we also evaluate functions using algebraic expression. Okay, thank you so much for watching.